My research is basically try to reconstructing the tropical Pacific climate variability from ice cores in Papua, Indonesia. Many Indonesians know that we have perennial glaciers in Puncak Jaya, but not many of them have seen them by themselves. I mean, there's not many images we saw in the television, in media like that. So that's why the ice core project that we did in 2010, we make some media coverage about how it's look like right now, and it's very interesting for Indonesian people to see that, and based on the local people that live near the Puncak Jaya, they really noticed the changes that they felt, because the snow is getting less and less, and the extent of the glacier is just getting retreat. The requirement to be there is a glacier is it has to be cold and a lot of moisture. And even in the tropical regions, if you have very high mountain regions, and like in Indonesia, in Papua, the elevation is like 5,000 meters above sea level, and that high elevations, the temperature is like 0 degrees Celsius during the day and even colder during the night. And as we know, in the tropical forest, a lot of moisture is coming off from the ocean as well as from the rainforest. So I think the glacier that happened there is just because the cold and the moisture that occurred in that high elevation. My research is basically to see the stable isotope composition from the ice cores that we revealed, also the dust composition, chemical composition, basically the major ions, to see what control the layer in the ice, and also we see how we want to see the past temperature and net accumulation in this region. There is only three glaciers in the tropical regions, one in the South America and the other one in the Africa. And Indonesia is the last one that has never been researched before. So it will be important to reveal information from these glaciers before it's disappeared, because the global warming has been revealed in all of the Earth. This region is very important because with the South America, we have known that we call the interannual variability, like ENSO, El Nino, and to see how the El Nino happened in the past from these glaciers is very important, because if we can understand what the mechanism of ENSO in the past, we can make an assessment for how it will be in the future. The impact of this event is very global. I mean, in Indonesia itself, when during the El Nino, we experienced very drought conditions, as well, and in the U.S. has a different impact. Drilling equipment has to be bring to the top of the mountains, and after that, after we get off the ice core, we bring it back here to Byrd Polar Research Center using the shipment, and then what we see from that, we try to cut the ice into small pieces to see how the composition of the ice. We do some stable isotope measurement here at Byrd Polar, as well as like chemical composition with the ion chromatography and also the dust composition as also done in the Byrd Polar Research Center. And from that, we try to date the ice core based on the result that we have, and then based on the time scale that we get from the ice core, we try to understand how the climate changed in the past from that region. And after we make that interpretation, we can compare that with the ice core record from South America. Actually, I've been interested in study science since I was in high school. I mean, my undergrad is basically mathematics, so I like science compared with like social science and other subject. But my interest in the climate science started when I've been working in BMKG. So at that time, I tried to understand how the climate changed, how the climate working on Earth, and this opportunity to study at Byrd Polar is giving me more valuable point about the climate itself.